All right, we want to do hypothesis testing on our beta hat, or well, really on beta. Now, so we'll first look at if we use a t-distribution. So suppose we have H0 null hypothesis that our beta is equal to some beta 0. And then the alternate is a two-sided test that says beta is not equal to beta 0. Okay, in this case, we can get a t statistic with n-1 degrees of freedom by taking our beta hat minus beta 0 over the standard error of beta hat. Okay, so we compute it that way from our standard error and so forth. And then we just check. We look for the probability. So we'll call this little p is the probability, our p-value, that the absolute value, that t minus 1, is greater than or equal to the absolute value of our b hat minus b0 over standard error of b hat. Now see, there's kind of a problem with notation in that that's our t statistic, so maybe I don't know, I'll call that t hat, because then this is just the general t distribution. So we look at that p, and if p is less than alpha, then reject H0 in favor of the alternative. And if p greater than alpha, fail to reject H0. Okay, so that's a hypothesis test for this thing. Now, typically, we use beta 0 equals 0 for our HO, our null hypothesis. Okay, and the reason for that is, this is to check independence versus dependence of our variables x and y. Because typically that's what we're interested in. Is there a dependence or not? And then if there is a dependence, what's that model? And so we would want to know what our b hat would be. And so, in this case, H0, beta equal beta 0. Gosh. Now let me just rewrite that so it looks a little better. Okay, beta equals 0. So, in that case, we have independence. Okay, because again, that would be a slope of 0. So we would see data that look like that if that's x and that's y, and yeah, I can't predict y any better by knowing x. But then HA is beta not equal to 0, and so that's dependence, because in that case, if I'm looking at X and Y, then, I'm seeing data that do something like that, and if I know X, I can do a better job of predicting Y. And so that would be the dependence. So it really comes down to, is that slope 0 or not 0? And so that's typically what you're going to see for this kind of hypothesis test. So in that case, what we're looking at is our t n minus 1 is equal to simply the beta hat over the standard error of beta hat. Because, right, B0 here, or beta 0, is 0. And so we just get that for our t statistic that we would look up. Okay, so that's a t distribution.